sequences, right? Just a quick recall on what we did last day. We did an arithmetic sequence, right? That followed this formula t to the n is equal to a plus, right? And we also did PubGP, where it's ar to the n minus 1, right? So these were two sequences that we looked at, and we looked at how to get all the terms for the sequence. So the first term is a, here is a plus d, here is a plus 2d, here, a, ar squared, and so on, right? So those are two sequences that we focus on, right? There are types of sequences that we need to know, right? The first type of sequence that we need to know that's kind of simple is one that's divergent, right? So a divergent sequence might look something like this. Let's say I gave you an AP with the first term 2 and the common difference 3. First term is 2, second term is what? 5, third term is, and the last term is what? All the way down to infinity, right? Yeah? This type of sequence is divergent. Okay? Anybody can give me an example of something that's convergent? GP, but give my actual example. Who said 1, 2, 3? Use A as 1 and R as 2 now. Like if I use R as 2, I'll get 1, 2, 4, and I'll keep getting bigger and bigger. 0 point. Less is a half, right? 0.5. Right? So if I were to list out this GP, it will be 1 by a half is that, by a half is 0.25, all the way down until what? Until it reaches 0. Nice? So that makes it convergent. That's okay? Anybody can write this a different way? How do I know if a sequence is convergent? Yeah, here man say it. Right, so a sequence is convergent if what? If as n approaches to infinity, right? We could say, write it properly. So a sequence is convergent if the limit as n approaches infinity of any sequence, a to the n, it approaches some value L, right? So as this sequence approaches at infinity, L approaches 0. L is 0, sorry. Okay, so this is a simple way to prove if something convergent, right? Or you can prove if something divergent. At n approaches infinity, you end up with positive or negative infinity there, right? True? Yeah. A of n is equal to L. Some value L. Okay, so make a note of those two types of sequences. But remember the simplify limits. Yeah. How? Right. So you can factorize it. So you have to determine it indeterminate first, right? Right. Factorize, if that doesn't work, you divide by the highest power, and then the third thing you can do is what? Which can work in unit 2. What the third thing you can do? The L'Hopital. Right? You can use the L'Hopital. That's okay? Right? So those are your first two types. So a sequence could be divergent, convergent, or what? One more thing. One more thing could also be. You can diverge, converge, or oscillate. It could be periodic. Anybody could think of a periodic function, you do it in tricks. Sine of cos of one of them, right? So y is equal to sine theta is periodic, right? So it might look something like this. You might start at 0, right? Then you go up to 1, then you come back to 0, then you go down to -1, then you come back to 0, then you go back to 1, and so on and so on. Right? So the sine function 0, then 1, then 0, then -1, then back up. So the sine function is an example of something that's periodic. Okay? So a periodic function behaves like that. Finish. Fine, ready? Right, so to determine, write this quickly. To determine if a series, sorry, to determine if a sequence is convergent, to determine if a sequence is convergent, to determine if a sequence is convergent, we can use the rule given above. We can use the rule given above. We can use the rule given above. That is, as n approaches infinity, that is, as n approaches infinity, the sequence approaches some value L. The sequence approaches some value L. The sequence approaches some value L. So stop. Let's recall how to simplify limits. Right, in order for you to simplify limits, you work it out in this order. Number one, the first thing that you can do is to factorize. Oh, by the way, simplify limits if indeterminate, right? Right, if it's indeterminate or undeterminate. right? So if you end up with something like infinity on infinity, or you end up with infinity on zero, something like that, then it's indeterminate. It's indeterminate, right? Then okay. Right. So if you end up with this now, how do you simplify the limits? Number one, you factorize. Only if factorization doesn't work, then you divide by the highest power. If these two don't work, then you probably do something wrong. But you can always check it with L'Hopital. Right? L'Hopital is you differentiate the numerator and the denominator until you get constant. Yeah. Huh? What the probability? Oh.
U.
Huh? Enumerators, any U or any U something?
It's not an E. And you get like no more. Yeah.
Right? So L'Hopital is the differential numerator and denominator, and the substitute when you get constant until you get constant. So you have to differentiate both the numerator and denominator. Constant. Right, remember if it's not convergent, it's divergent, right? But they want to give them here n minus 1, n plus 1 and 1. Right, so you want to determine if convergent, right? So you want to see the limit at n approaches infinity of a to the n if you're going to get a value, right? So I want you to be able to simplify this. So try this a minute. Try and see when you finish, if you could apply back the unit 1 rules and see what you get. Right? Is this indeterminate issues? I mean, Shavish? Is this indeterminate? Yeah. When you plug infinity in here and you plug infinity in there, you will get infinity on infinity. Yeah. So apply that to me now. Apply one of the rules and see what you can do. Apply one of the rules and see what you end up with. If you can't factorize, you divide by the high power. Right? So you can't factorize nothing there, right? Divide by the highest power, then plug in infinity and see what you get. What is 1 over infinity again? 0. 1 over infinity is 0. Right, so you remember this module has sequences, series, binomial expansion, Maclaurin's expansion, Taylor expansion, and estimating the roots. Right? So it's a nice module once this will come to hard. Right, so will I get you? Again, so you can't factorize, so divide everything by the highest power. What's the highest power here? N, right? N is the highest power, right? So divide everything by N. So it'll be N on N plus 1 on N plus N on N. You divide every single one by N. Right? You will end up with the limit as N approaches infinity of 1 plus 1 on N on 1. All we have to do is substitute infinity. You'll get 1 plus 1 on infinity and 1. This is 0. So you'll end up with 1 plus 0 on 1. So it's 1. Yeah, you can simplify it. So therefore, what you could do here is say that it's convergent. Right? It's convergent. Any questions online? Huh? So how is N the highest power? Well, I should say divide by the highest power of X or the variable, right? So the highest power of N here is 1. So you're dividing everything by the highest power. So for example, here's what that statement meant, right? So here, if I can't factorize fully, or not to factorize here, right? Let's say I had that and I can't factorize good, right? The highest power of X here is 4. So you're dividing everything by X to the 4. Here, the highest power is N. So you're dividing everything by N. Right? The wording was a little off in that, right? So you're dividing every term by the term with the highest power, which is technically what you might have to do here. 5n squared all over 3n squared plus 2n plus 1. Try that fast. Yeah, that has a 3. Oh yeah, try that fast. Should be showing what on the previous one did. If you like, what are you doing now? You're right. Oh, bring it up. Yeah. Oh, by the way, you should all use the hospital, right? So if you differentiate, you will get one, differentiate, you will get one. Huh? No, no. You differentiate the numerator by itself, denominator by itself. Right? Come to me, somebody go and do that. Huh? Come on, we can. Right? How much you got? 503. So can we have factorize? No, right? So we can divide everything by n squared. When you plug in infinity, right, you'll get 5/3 plus 0 minus 0. So the answer is 5/3. If you know, if you say using L'Hopital, so we can use L'Hopital now. Right? So if you use L'Hopital and you simplify it, here's how it does work, right? Right? If you use L'Hopital, you can differentiate the top, you'll get 10n. Differentiate underneath, you'll get 6n plus 2. Right? But you can't, you're not done. Because if I put infinity in here, I will still get indeterminate. Okay? So you go one more time. So you do differential again on top, you'll get 10. Differentiate underneath, you'll get 6. And that's it. Reduce it and you get the same answer.
Yeah.
Yeah.
That makes.
One more. Any questions online? Nikolai, stay quiet now. Try that fast. Oh yeah, do that fast. Last one. We got that. Right? There is something you can do with the root to make it work a little easier, right? Right, so why we pull the root on the outside, right? Right? Pull the root on the outside and then do your thing.
Just pull the root on the outside. We
So what do
need
you
to try
do? Why you go to the root right there? So you pull the root out, right? Right, so technically, you just work with the roots on the outside. Right, that's one of the rule of indices, you can pull the roots on the outside. Right, and then we can apply L'Hopital. If I differentiate here, I'll get 12. If I differentiate here, I'll get 3. Right, so therefore, this is square root of 4, which is 2. Huh? No, the first thing I did is I pull the root on the outside. Yeah, that's a rule. Fill in the limits rule. Right, you can put it outside, you can put constants outside and things. Okay. That's one option. And next option is you could have also written that like this. The square root of 12n plus 3 over the square root of, and then you chain rule here and here, and then simplify it out. Right? You could have also done that, but you end up with the same thing. If it is proper. Right? But remember, you can pull the indices outside. That's a rule pull outs, right? For limits, right? So you could, if you never heard that before, there's this rule. Right, that way. Right, we can write like this if you want. K to the n, all to the k, you can pull the k like this. All right. That is limits. Let me give you one more. So this one came once. Last one. Yeah, look at it. Last one. Hurry up. Oh no, I'll just write in the rule that that's used. Finish? Play again. Oh yeah.
D ทำได้ zero ดีทำได้ zero ไอ้ทำได้อาจจะดีทำได้ zero
Take log from them. Take log.
เวียนเด็กแล้วสิกัน
Right, what can I do here, Ranju? What can I do with a tree? I can put it in front. Right, so I'll end up with this. Can I use this rule here? Like pull out the n minus one? No, this is not constant. Right, this n here, right, is the variable that we're using here. It was a half constant here t. So we can't pull out n minus one. So what we might have to do is something like this, right? Or we could possibly do here is just 1 by this and 2 by this. That's all we can do. Yeah. 1 to any power is what actually? 1 to any power is always 1. It don't matter what the power is, right? And if I plug in infinity here, what will I get? If I plug in infinity here, I'll get 1 on 2 to the infinity. Right? 1 over infinity is what? 0. So I'll get 3 by 0, which is 0. So it's convergent. Questions online? All right, yeah, that's a good point. So here what Tavisha recognized, right? She recognized that this is a GP. You recognize that? And she said GP is always convergent when R is between 1 and minus 1. Right? She said that there. R is a half. You see that? So you can actually say that rule. Right? I give it a yes, give it a top one. I give them no two top. What's that? Yeah, I plug in infinity here. To the infinity, infinity. 1 over infinity is 0. Any questions online? All okay? All right. So sometimes you're going to see sequences looking like this, right? Sean, some of what kind of sequences is here? Sequence. What kind of sequence is here now? Here. Alphabetical order, right? Sometimes you will get sequence like that. Right? Sometimes you might get a sequence looking like this. U to the R is equal to, let's say, 3 U to the R. What does this mean here? What does this mean? And they would start here, U1 and 2. How do you find sequence? How do you find the terms in this sequence? What you do? You need the previous term, right? So to get the preceding term, you need the previous term. Right? So for example, if I say when R is 1, I'll get U2 is equal to 3U1. And the only way I can figure out U2, Vinaya, is I must know U1. Right? So this will be U2 is 3 by 2, which is 6. So the only way I can figure out U2 is if I know U1. The only way I can figure out U3 is if I know, right? So U3 is what? Based on the formula. U3 will be 3, U2. But R is 2, R is 2, right? Huh? Yeah. Maybe we ain't reaching out with it. Who said the loss? The loss?
Yeah.
All right. So therefore, U3 is equal to 3 by U2, which is 6.
Let's try by 2.
No, 3 by U2. So therefore, the sequence is 2 push-ups. Right. So watch here. Some sequence will follow something like this. I'll give you the name of this just now, right? Some of them follow Nikolai. Do you think we are not paying attention? Right? Some sequences look like this. To figure out the preceding term, you need the previous term. So for example, for me to get U2, I need U1. To get U3, I need U2. Right? So some sequences look like this. And of course, I will start here up and tell you, well, U1 is something. So to get U2, it will be 3 U1, so I got U2 as 6. To get U3, 3 U2, I got 18. So the sequence looks something like this. That's okay? Right? This type of sequence is known as a recurrence relation. Right? So head of recurrence relation. Okay, follow this. Yeah? So to figure out to get U4 3, what will it be? U4 be what? 3 by U3. So U4, which is 3 plus 1, will be 3 U3. Right? And U3 was 18. Head of recurrence relation. A recurrence relation occurs when to take a small note. Right? To make it thing look worthy. Just to make it look a little worthy. A recurrence relation occurs when a recurrence relation occurs when a previous term is needed to find the preceding term. A previous term is needed to find a preceding term. All right, and I'll give you an example here. Copy that down. Untuk penunggu namun example. Kelihatan dalam yang
You don't fix it.
pegang di quarter manufacturing market.
3 by 18. And it'll be 3 by 3 by 18.
Finally, finish. Hello. Allora, il fatto solo, pure
It's like a break. I go to one. I don't write it, so it's only one of one thing.
Right, number 2. Write the first 4 terms. Number 2. Write the first 4 terms of the recurrence relation. If it's 1 person, they didn't know it. 1. Find the first 4 terms of the recurrence relation Find the first four terms of the recurrence relation. U to the n plus one is equal to four u to the n minus two. All right, take care for you. Where u1 is equal to minus one. U to the n plus one is equal to four u to the n minus two, where u1 is equal to minus one. Find the first four terms. That's all. Right, let's see what you got. Them a cruising. If you look at all my shoes, are like flowers, no, no, thing, right?
Yeah, all your shoes.
And I have pants on, I short pants. Huh? Not if you short pants, like about here,
But I have things there.
right, U2. That'll be 4U2 minus 2. Huh? Right, so it'll be 4U1 minus 2. So that'll be 4 by minus 1 minus 2 minus 6. And U3 will be 4U2 minus 2. So that's 4 by minus 6. So that'll be minus 28. And U4 will be 4. 24 minus 2 here. 4U3 minus 2. So 4 by this is how much? 1. Right. So that'll be minus 106. Minus 106, right? So the first 4 terms is minus 1, minus 6, minus 26, minus 106. Right? Of course, it wouldn't be this easy. I'm gonna give you a past paper. Yeah, the first 4 terms. 1, 2, 3, 4. All right, still 1, 2, 3, 4. I only want the first 4 terms. Next one. Given. What I doing, boys? Are you hungry?
Yes.
Right, given UR plus 1 is equal to 5 on UR minus 4. R is more than or equal to 1. And U2 is equal to U1. Find the possible values of U1. Right, so U to the R plus 1 is 5 over UR minus 4. R is more than or equal to 1. And U2 equal to U1. Find the possible values of U1. Look, I give it any second. I was saying, I'll give it an answer. Fine. Yeah, U2 equals to U1. So my advice here is the equation with something in it. I can't remember yet. Ready? Right, so the only thing that I can give you is to find U2. Use the formula and find U2, and then something magical will happen. So find U2. Easier than that. Oh yeah, you done? Yeah. Try something. Okay, going to so far. Please YouTube. Please YouTube. Right now we place YouTube. Right? So some of you all have this, right? Some of you all have U2 is equal to 5 on U1 minus 4. Nice. But what do we know about U2? U2 is equal to U1. So can I just replace U2 with U1? First multiply, get a quadratic and solve. Yeah, okay. So then you should get a little quadratic. Oh yeah, so that you should get two values, right? So it is done quadratic and solve. The problem. All right, so when they cross multiply here, you'll get U1 by U1 minus 4 is equal to 5. So you'll get U1 squared minus 4U1 minus 5 is 0. When you solve, you'll get U1 is minus 1 and 5. That's okay? So you'll get quadratic and you solve it. Let's go again. So we can do one more at least. Right? I didn't get to do the PMI, right? But that's what we'll start with next week. Right? I give you half some time to go over and read how to do a PMI. I'll give him more time to go and read it again. No, gotta go down. Oh, yeah. So I'll give you a different thing. U to the n by U to the n plus 1 by U to the n is 2 to the n. Right? I want you to find prove this and find U3 and U5. Oh, yeah. 2 minutes to write it down and then 3 minutes to work it out. Same thing like the last one, set up an equation and work it out. Iya, kapal naman sa ibu natin. Right, so you have to prove that, right? So just like here, we had to get U1 and U2. Here, we had to find a way to get n plus 2 and n. All right? All we had to do is find a way to get n plus 2 and then see how we can substitute and work it out. Okay. Very quick. When you have 2 minutes, think again. Can't you finish? Alright, so what you say? What you say? So here's what we have, right? Here's what we have. We know that u to the n plus 1 is equal to 2 to the n on u to the n. I'm just using this statement here and I get it. Right? So I just write this like this. But okay with that? So I want to find a way to get u to the n plus 2. So can I let n equal n plus 1? So I'll get n plus 1 plus 1, which is n plus 2. What would I get here? 2 to the n plus 1. What would I get here? Sorry? Right? So if I let n equal to n plus 1, I'll get n plus 1 plus 1, n plus 2, n plus 1 here, n plus 1 here. That's okay? So I put n for n plus 1. Technically, I just added 1 on all the n's. Y'all see enough? Right, but now how does this become this? Right? So I can simplify this a little bit. Right? I can simplify this and write it like this. 2 by 2 to the n all over u to the n plus 1. Correct? Plus 1 means this, right? So I could write it like that. What this is? This, right? If I switch places here, I'll get u to the n is 2 to the n over u to the n plus 1. Right? This is u to the n. So I can substitute that and get 2 u to the n is equal to u to the n plus. Right? Timothy? Real easy, eh? Timothy, since that was easy, how you getting u3? Huh? How again u3 here? N equal to what? N equal to what? 1 plus 1 is? Right, 1 plus 2 is? 3. So that'll be u3 is equal to 2u1. Correct? So u3 is equal to u1, they gave us u1 somewhere, is 2. So u3 is equal to 4. Right? Last one, 3. How again u5? How do I get u5? Let n equal to what? N equal to 3. So I'll get 2 u3. So that's 2 by 4, which is 8. Yes, sir. Possible question. Right? So all the questions here are past papers, right? Copy them down. I want to run PMI, right? I'll start with PMI next. Okay? So, one. Alright, that's the audio. Alright. Copy it down online. Online you also log out, right? So we do it PMI next week. Nah, what? We are 1 to 1, I'm going inside. Okay, just do like you. Okay, just do like you.
If you want to do it outside,